The equation for the reaction to produce hydrogen is given below. Explain why changing the pressure does not affect the yield. Well, now this seems initially a bit silly because we've just learnt that pressure does affect the yield. And you'll remember, of course, that when you increase the pressure, it goes to the side with the least number of particles. So let's have a look what's going on here. 1 carbon monoxide, 1 water. There are a total of 2 particles on the left-hand side. 1 carbon dioxide, 1 hydrogen. Total of 2 on the right-hand side, and this is why it doesn't affect the yield, because you have the same number of particles on both sides. So same number of particles on both sides. Right, okay, so next part, let's have a little look at that. Right, for the next part, where's my page 2 gone? Is it on the back? Yeah, it is. Right, so here we go. So next part, suggest why the best yield of hydrogen is obtained at low temperatures. Now this is a little bit tricky because what they've done here is they haven't really given you too much of a clue as to what they're getting at here. But what you need to appreciate is if they're talking about yield and they're talking about temperature, this is going to be linked to whether the forward reaction is exo or endothermic. So it's a low temperature. So what does that mean? Well, in your reaction, it means that you get, let's say, a large amount of product at a low temperature. So you will remember, I hope, that when you do something to your system, it tries to do the opposite. So if you are looking at lowering the temperature, it will try and heat itself up. So therefore, if it's a low temperature and it's trying to heat itself up, that means the forward reaction must be exo, because you've reduced it and it's gone in the exothermic direction. So that is what they're after here. They're after the fact that the forward reaction is exothermic. Right. Okay, next one. Straight up rates question here. So temperature used in industry needs to be high enough for the reaction to take place quickly. Explain in terms of particles why the rate increases when the temperature is increased. Okay, so hopefully this isn't too bad. So when you increase the temperature, you will get the particles move faster. So that's the first point. All right, second point is that if they are moving faster, then quite clearly, all right, there will be more successful collisions. And a third point will be that more of those particles will have energy that is greater than the activation energy. Right, so what does that mean? Well, just think about this. So these things, obviously you heat them up, they move around faster. Quite obviously, there will therefore be more collisions. All right, and if they are moving faster, each of those collisions will be more energetic. So therefore, there will be more successful collisions, as in there will be more collisions that actually make a reaction. And the technical term for those collisions that make a reaction, if you like, is the activation energy. Remember, that's the minimum energy that these particles actually need to react. Right, and the last part of this bit says scientists have developed catalysts which allow the reaction to take place quickly at lower temperatures. How could this be good for the manufacturer and the environment? Okay, so for this particular one, right, you're obviously looking at 2 answers here. All right. In terms of well, I mean, there's lots of things you could have here, to be honest, because yeah, there's loads of things that your manufacturer's going to want. All right. So first up, the obvious one probably is the fact that you're going to be reducing costs. Okay. So I'm going to write all the possibilities here. You don't need all of these. Reducing costs. If you have got a catalyst, you're going to get more product, not in total, but in a given time. Because obviously, remember, it speeds it up, doesn't it? That's the whole point of a catalyst. And in terms of the environment, there is going to be less CO2 produced. Why? Well, because carbon dioxide is going to be a emission that's given out when you heat things up. So basically, if you're doing this at a low temperature, you'll get less CO2. Try and steer away from writing things like less pollution, because they're not going to give you that. All right. So they're always going to want something specified. So carbon dioxide is always a good go-to. That's generally what is produced as a byproduct of burning things. And I guess you could also say that you would need to use less resources, because of course, if you're not burning things to generate your energy or using your electricity to generate your energy, then less resources will be used.